I'm going to recap ENFSI exercise 1. EuroForMix is designed to offer different functionality and methods of analysis, but these are mainly for specialist applications. For routine casework analysis, we recommend that it would be much easier if you use the easy mode, because this will automatically direct you towards the method that we recommend for casework. To recap the circumstances of the case, a man was stabbed in Madrid. Biological remains under the nails of the victim were collected during the autopsy. After the DNA analysis, a mixture was detected. The judge wants to know if the suspect contributed to the mixture. Reference samples from both victim and the suspect are available for analysis. So here is the GUI. The first step is to load the data, and don't forget to use the easy mode, which you get from File, Settings. The parameters are input into here. Press the yes button here, and then don't forget to save. So here we have the identifier kit, Spanish population, the evidence is here, suspect, victim, all ticked on. And the first step that we carry out is to press the View Evidence button, and that gives us a representation of the EPG, where you can see that the suspect is the minor contributor and the victim is the major contributor. And we also see the degradation pattern, classic ski slope, where the peak heights of the low molecular weight fragments are much higher than those of the high molecular weight fragments, and this of course is a classic degradation pattern, and we'll be using this information later on. So the step 2 is to use the model specification tab in order to highlight the casework scenario. So here we tick the suspect and the victim. Under the prosecution hypothesis, under the defence hypothesis, we only have the victim and an unknown individual. Now when we start the analysis, we make sure that we set the degradation button and the stutter button to no, and then press the continuous LR. And then this leads us to the MLE fit tab. So here we have the mixtures, mixture proportions. The suspect under the prosecution hypothesis is present at a level of about 26%, and the victim is about 74%. And these same mixture proportions are found under HD. Here we've got the victim is given first and the unknown individual is given second. What we're going to take notice of is the log likelihood value over here. It's minus 338.8, and we're going to use that in the model validation. So the next step is to determine the effect of including the degradation model. So we go back to the model specification tab, and then we press the degradation button here, and then just do exactly the same thing as before. Press the continuous LR button, and you can see the same GUI under the MLE fit tab, but this time the log likelihood has changed. The number has actually increased. It's now minus 331.1, whereas before it was minus 338.1. So this value has increased, and that indicates that the model is better than the one we tried before. But notice that the likelihood ratio is almost unchanged. It's still log 10 to the 15. So all we do is we just go through this process over again, changing the model, and then make a note of the log likelihood in this column and the log 10 likelihood ratio in this column. So when we use a model without degradation and without stutter, the log likelihood is minus 338.8. With degradation, without stutter, we got minus 331.1. And if we repeat this for the other possibilities, that is the no degradation and with stutter, minus 338.8, and with degradation and with stutter, minus 331.2. Now we have to take account of a penalty, because each time we include an extra parameter, then we need to penalise the likelihood by -1 for every parameter that we include. So if we include degradation, then it's penalised by -1. If we include degradation with stutter, then it's penalised by -2. And if we recalculate these figures, we still find that the best model is with degradation but without stutter, because that gives us the largest value. It's minus 331.1. So this is the model that we will choose to use. But notice that the likelihood ratio itself changes very, very little regardless of the model which we use. So we go back to analysing the model with degradation and without stutter, and there's a log likelihood there. And the next step is to carry out the model validation. So we press these buttons here and here. So these points should form roughly a straight line. The red envelope here represents a confidence interval, and these points should not fall outside that interval. Otherwise we may regard that the gamma model is actually invalid for that particular sample. However, with this example, they are reasonably straight line fits. The next step is to carry out the LR sensitivity test. Now this is an MC test, and it's useful to set the number of sample iterations to 5,000. The more iterations you have, the better it is, because MC varies between runs, and that variation is reduced if you have more sample iterations. So we recommend that you set this number here to 5,000. And once you've done that, you simply click on the LR sensitivity button here. And what this plot shows is the errors across the parameters, and we are reporting the 5% quantile, and this is 14.3. Remembering that the mean here is about 15. So the number, of course, is conservative and a little bit less than the mean illustrated here. So the reported likelihood ratio is log 10 to the power of 14. So in the next talk, I'm going to carry out a comparison with EuroForMix Studio, and I'm also going to make the model more complicated to show you some of the interesting properties.